I'm Brian Carney. I'm a professor of civil engineering at University of Toronto. We're here this morning at Pharmacy Avenue plant of IPEX, and we're going to take a sample of pipe, 24-inch diameter pipe just over here, and we're going to pressure test this to destruction. This test is done by taking the sample of pipe and filling it up with water. That's done by using a positive displacement pump that's just behind me, and it fills through a line into the one side of the pipe. The pipe is filled with water, and then it's entirely sealed. And then we're going to read the pressure that's within the pipe by several pressure gauges that are going to be mounted both inside this chamber over here as well as on a wall on the outside. This is a DR25 pipe, which means that the ratio of the diameter of the pipe to the wall thickness is 25. Nominally, this pipe will have a pressure rating that will be written on the pipe of 165 pounds per square inch. That's about 11 atmospheres or so in terms of total pressure. But what we'll find as we test it, that the pipe is quite likely going to be capable of experiencing higher pressures than that. This is a viscoelastic material. Vinyl pipe is made of a polymer type material, and it's able to withstand quite strong pressures, in fact very high pressures, for short periods of time. If it's under a longer duration test, then we'll find that the pipe will be closer towards its pressure rating, although there's even a considerable safety factor that's built into that. Okay, we've reached 100 psi at this point. Now the pressure has reached 160 psi, which is just at the nominal pressure rating of the pipe. And now we're 165, so we've just reached the pressure rating. Now the pressure has gone up to 200 psi. So the pressure now has gone up to 300 psi, so we're at 20 atmospheres of pressure in the pipe. The pressure has gone to 400 psi at this point. Just as a rough guideline, the 400 psi would probably be equivalent to a force of about 200,000 pounds acting on that restraining wall. .500 psi. .520 psi. 540 psi. 560 psi. What happened during the test is we brought the pipe up to 560 pounds per square inch, and at that point we decided, since the cage at that point wasn't on, that we would release the pressure a little bit, and so we took the pressure off and stopped the test, turned off the pump so the pressure was no longer accumulating in the pipe, and at that point we dropped the pressure down to 300 pounds per square inch, and then we put the cage over top of the pipe so that everybody would be protected. Then we repressurized the pipe again. And during that final test, the pipe got up to a final maximum pressure of about 560 pounds per square inch, at which point there was a very sudden and loud noise and bang and an explosion, and the pipe released and caused these breakage in the pieces that are around, as all of that sudden energy that's in the water and in the pipe wall was suddenly released. The pipe that we tested was nominally rated at 160 pounds per square inch. And then the pressure was brought up, and ultimately the pipe did fail at 560 pounds per square inch. It was interesting, the pipe, there was no visible leakage, but there was a visible swelling of the pipe during that pressure testing. That swelling was associated with the increase in pressure and the straining that took place in the pipe wall. One of the things that's very evident and relevant through these tests, though, is that plastic pipe, with its unusual set of characteristics with this viscoelastic property, is another tool that the engineer has to consider as a relevant one in the range of tools that are used for solving various hydraulic and structural problems. It's one that needs to be considered along with the other range of options that are present. Valuable tool in the toolbox.